I can show you the world. 3.2, parallel lines. Yesterday we did lines that were not quite parallel. They were kind of off, and we got a whole bunch of vocabulary off of them. Today we're going to go ahead and change it so they're exactly parallel. Let's look to see what happens when we make lines parallel, because a lot of very specific things happen. I know it's kind of hard to see, but if you see this little double arrow, there's two little arrows in there. Whenever you see those arrows on lines, that's the way we denote parallel lines. So if you see the arrows, that means the lines are parallel. All right, so when we make two lines parallel and we cut it with a transversal, we have these 8 angles again that you guys learned the vocabulary for their angle pairs yesterday. But today, when the lines become parallel and they're not jagged, then we have real very specific rules. For example, in this case, we have corresponding angles postulate. A postulate is just basically a mathematical rule that doesn't need to be proven. Okay? And so let's go ahead and look what happens when we make the lines parallel. If two parallel lines are cut by a transversal, and this is what we have, two parallel lines, they're cut by a transversal, then each pair of corresponding angles is congruent. All right, so you have to remember what corresponding angles were. So this theorem says if we have parallel lines and it is cut by a transversal, this thing right here, then all of the corresponding angles, this angle and this angle, those A and C are called corresponding angles. If we have parallel lines, it turns out that angle A is always going to equal, we'll write angle A is always going to equal angle C. All right, and that only happens when the lines are parallel. But those aren't the only corresponding angles. We also have E and G are corresponding angles, and they're going to be equal to each other. We have B and D, they're corresponding angles, and they'll be equal to each other. And then also F and H are corresponding angles, and they are also equal to each other anytime we have parallel lines. All right, so those are the types of rules we're going to be dealing with today, and there's a whole bunch of rules, so hang tight. Let's look at some of those rules, or theorems. Theorems are mathematical rules that do need to be proven, and we will spend this chapter proving these things. There is a theorem for alternate interior angles. Let's try to remember what alternate interior angles are. Here's an example. Angle B and angle G are alternate interior angles. According to the theorem, all alternate interior angles are congruent. So angle B and angle G will be congruent, again, only if the lines are parallel. Also, another pair of alternate interior angles is F and C. They are alternate interior angles, and they are also congruent. Okay? How about a theorem for alternate exterior angles? For example, angle A and angle H. Those two are alternate exterior angles. According to this theorem, alternate interior angles are also congruent. So A and H are going to be equal, and then we also have angle E and angle D. They are alternate exterior angles, so they are congruent. Okay. How about consecutive interior angles? Here we have angle F and angle G. They are consecutive interior angles. Their rule is a little bit different. They are not congruent. They are supplementary. So F and G are supplementary. Hopefully you guys remember what supplementary means. Supplementary angles means that when you add them together, they equal 180. So F and G, when you add them together, equal 180. Also, B and C are consecutive interior angles, so they are also supplementary. They also add up to 180. And then we have one more. The perpendicular transversal theorem. The perpendicular transversal theorem says if you have one angle that's 90 degrees, then all of them will be 90 degrees. Okay? And so that's what we call the perpendicular transversal theorem. And just so you know, all of these theorems are true only if we have parallel lines. If there's no parallel lines, then none of these theorems will be true. Okay, so keep that in mind. Okay, so let's go ahead and do an example. You'll be given something like this, and then you'll be asked to solve for x and y. Notice the very first thing you have to notice is these little arrows. And I know they're really hard to see, but as soon as we have those arrows, which means those two lines are parallel, then we can use all of those rules that I just listed out. All right, so let's solve for x first. Notice this is 100 degrees, and then there's x. If you remember from the very first chapter we did, when two angles make a straight line, they should add up to 180 degrees, okay? And so x has to be 80. And if you want to review the vocabulary word for when two angles are together and they form a straight line, remember the vocabulary word from chapter 1 was called linear pair. So linear pair. So if the homework asks you why is x 80, you just say that x is a linear pair with 100 degrees. All right, so from there we can easily solve for y. Notice x and y are corresponding angles. So when you have corresponding angles and you have parallel lines, that means that they are going to be equal. And so y is also going to be 80 degrees. All right, that's how we do these types of problems. Okay, let's throw a little bit of algebra into this. Notice again, we have these little arrows, which means they're parallel, which means all those rules are good. How does this angle relate to this angle? Okay, they are alternate exterior angles, and according to the rules, alternate exterior angles are going to be congruent. They're equal to each other. So we set it up so that they're equal to each other. 3x minus 7 is equal to x plus 4. Go ahead and use your Algebra 1 skills to solve that. Combine some like terms, divide 2 to both sides, and you should get x equals 5.5. See, the algebra is not too hard. So let's go ahead and do a tricky example. Here's some lines that look like they're intersecting all over the place. Notice that we do have these little arrows in there. That's important. That means that those two lines are parallel. So then the rules apply for those two lines only, not the other lines. All right, so let's go ahead and find all the angles. And then it's your choice what order you want to. But angle 6, or that angle 65, should match this angle, 65 degrees. Remember the vocabulary word for that? Vertical angles. So vertical angles are equal. Well then, wouldn't that work for the 45 and this one? It does. We have 45 degrees there. All right, so we filled those in. Let's see what else we can fill in. Well, notice these make a straight line. So that means that all three angles there are going to have to add up to 180. So how do we figure out just this angle? You add the 65 with the 45 and subtract 180 to get 70. Okay, and then you can do the same thing on this side too, or you can use vertical angles again to get 70. All right, so it was easy to fill out this part of the picture, but now we're going to jump over to this part. What about this angle? Notice that we have these two parallel lines cut by a transversal. This angle right here has a relation to this angle. If I draw it on the side to make it less confusing, there's these two parallel lines cut by a transversal. We have this angle and this angle. Remember, those are called corresponding angles. And so corresponding angles are equal, which means that angle is 65 as well. Okay. And then from there, we can find the vertical angle to 65. And then from there, we can figure out that these two are a linear pair. They make a straight line. So that means that's 115 to make 180. And then, of course, vertical to that is also 115. All right, it looks like we're almost done. We still have a few more to do. What about the angle on top? Oh, there it is. I actually accidentally answered it, but this angle and this angle have a relationship. If you want to draw out a separate picture, here are our parallel lines again, and it's now cut by this transversal. This is the angle that we were looking for, and this is the one that was 70. And so they are corresponding angles. That's why this is also 70. And once we get that, we can easily find this one because that angle is a linear pair to the 70. These two make a straight line. So we have 110. All right, so that's kind of fun. You have all these missing angles and you can use your rules to find all of them as long as you have parallel lines. All right, let's go ahead and finish the notes with one last slide. Here we have a trapezoid. All right. They're asking you to solve for x. I know the directions aren't there, but you have to solve for x. And so you think, well, how am I supposed to do that? Well, if you notice, look at these little arrows. That just means that you have two lines that are parallel. And then if I cut it right here, then we have this angle would be here. And then this angle would be here. And then if you remember the relationship between them, they are consecutive angles. Consecutive angles, or if certain books call it same-sided interior angles. Okay? And then if you remember the rule for consecutive angles, they're not equal to each other. They are supplementary to each other, which means they add up to 180. So let's go ahead and do that. Let's make them equal to 180. The x minus 5 plus the 3x plus 7 equals 180. Combine some like terms. Let's do a little bit of simple algebra. Let's divide both sides by 4, and we get 44.5 for x. All right? So that is it. It's just recognizing the rules for each of the specific vocabulary pairs and then applying it properly. Okay? So go ahead and try the homework.